Here's our starter for today. If Mars, as in the planet, is known to have a radius of 3.4 times 10 to the 6 meters and a mass of 6.42 times 10 to the 23 kilograms, what should be the gravitational field on its surface? Or, in other words, the acceleration of gravity on its surface. And knowing that, if you drop a rock off a cliff on Mars, and it takes 8.2 seconds to hit the bottom, how high is the cliff? Well, let's do number 1 first. And let me zoom out. Well, start off with this equation. The force of gravity is equal to mg, which is equal to the gravitational constant times the mass of my planet times the mass of the object on the planet's surface, in this case, divided by r. And so if you cancel out the mass of your object, this should tell you what the acceleration of gravity is, or the gravitational field is, on the surface of that planet. So this will be the radius of the planet, this is the mass of the planet, and that's what I gave you, and that's all you have to use. So this is 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared, times the mass of Mars, which is given to be 6.42 times 10 to the 23 kilograms. And you divide that, by r squared, sorry, that's r squared. What is r? 3.40 times 10 to the 6 meters. And we're going to have to remember to square that, which I forgot to do when I wrote the equation down. Now, get out my calculator, clear it up. Okay, so we've got 6.67 times 10 to the negative 11 times 6.42. Use the EE button. Don't use that times 10 to the caret thing. Okay, 23. Divide by 3.4 times 10 to the 6. Don't forget to square that. And that equals, and I get 3.70. We'll call it 3.7. Well, meters per second squared, if you like. Or if you cancel out these units, this is meter squared, right? Canceling the meter squared. This is 1 kilogram. Canceling that, you get newtons per kilogram, which is what we measure gravitational field with. So 3.7 newtons of force for every kilogram of mass. Or you can think of it, if you drop a rock on Mars, it will accelerate down at 3.7 meters per second squared. Maybe a little more than a third of the acceleration of gravity here on Earth. So you're going to feel a lot lighter on Mars. You'll feel a little bit more than a third of your weight on Mars. Mars has less gravity than Earth. So now I can use this for this next part. If you drop a rock off a cliff on Mars and it takes 8.2 seconds to hit the bottom, how high is that cliff? Well, let's go ahead and use given, find, and solve, which I should have done in the first problem. Here's our cliff. Here's our rock. And the initial velocity of that rock is 0. You're dropping the rock, so that's kind of implied. At the very bottom right here, we say that time is equal to 8.2 seconds. And we know that g is equal to, let's say down is negative, so that's actually negative 3.7 meters per second squared. And what are we trying to find? Well, we'll call it delta y for now. That'll give us a negative answer, but we know what we mean, how high the cliff is. And so this is just like the free fall problem that will be on the test or on the final exam. The one on the final exam, though, is just on Earth. Okay, I didn't do this crazy thing on Mars. But I just wanted you to see that all this physics that we learned on Earth can be applied to any planet. And we're trying to find delta y. We know the initial velocity. We know the time. We know the gravity. So we'll use the third kinematic equation. Delta y equals v naught y times t plus 1/2 a t squared. Of course, this is 0. We'll plug the values in here. So delta y equals 1/2. Instead of using 9.8, what are we going to use? 3.7. We'll go ahead and make it negative 3.7 meters per second squared times this time squared, 8.2 seconds squared. So get out the calculator. 0.5 times 3.7 times 8.2 squared equals, and it should be, 124 meters. That's what I got. Now I'm going to just say, okay, delta y equals negative 124 meters. But what does that mean about the cliff? You would say the cliff is 124 meters high, or, you know, you would have to rappel down 124 meters, right? So there's our answer. The rock drops 124 meters. Okay? And that's how you do that. Any questions? That is all.